Hi, I'm Adam Radley. I'm the founder of IIMAGINE. This is the first episode in a series of videos and podcasts about the impact of AI and related technologies on all aspects of society. But we have to start at the beginning. It's going to be pretty difficult to talk about the impact of AI on society if you don't have a basic understanding of what AI is. Some of the existing explanations of AI are too technical, and some, like those from the media, are so simple that they're completely useless. The one thing that all of these explanations have in common is that they're missing important information that you need to know. Why do you need to know? Well, it's obvious that people that know how to use this technology will have a massive advantage over people that don't. So you need to learn some very basic fundamentals about how it works so you can understand what it does well and what it doesn't do well, and use that information to make decisions that impact your life and your community. So in this first episode, I'm going to give you a quick, non-technical explanation of AI and what it can do well and not do well. All of the other episodes in this series will be non-technical episodes about the impact of AI on society. So if I mention a term in a future episode that you don't understand, you can always refer back to this episode. So let's get started. This is what we're going to cover. There's a lot of AI terminology that you've been hearing about but probably don't understand. I'm going to give you a 2-minute explanation for all of them. What is AI? What is machine learning? What is transfer learning? What is generative AI? What's a vector database? What's a large language model? What is natural language processing? What's a neural network? Okay, so what is AI? AI is a broad term that has a lot of definitions, but I define it this way. AI is the simulation of human intelligence by machines. There are a lot of other more technical definitions, but the reason I'm suggesting that one is that I'm focused on a non-technical audience. But the reality is that AI is a very broad field that includes everything from rule-based systems to complex machine learning, so we do need a simple and broad definition. I'll explain what rule-based systems and machine learning means in a few minutes. Siri, Alexa, and Google Assistant use AI to understand your commands and attempt to respond appropriately. They can schedule reminders, play music, and answer questions. Then there's recommendation systems. Platforms like Netflix and Amazon use AI to suggest products or shows that you might like based on your past behavior or based on the behavior of other people like you. Okay, what is machine learning? Machine learning is a subset of AI that involves using algorithms to analyze data, learn from it, and then make a determination or some prediction about something in the world. So it analyzes data, looks for patterns, and then uses the pattern to make a prediction. So rather than being explicitly programmed to carry out a particular task, machine learning algorithms learn from experience. They perform well in situations where the quality of data is large and the task can be clearly defined and measured. But they can struggle with tasks that involve high-level reasoning, a lack of data, or that require a deep understanding of the world. Then there's spam filters. Email services use machine learning to classify emails as spam or not spam based on patterns identified in the content of the emails. So this does not work by programming Gmail to label an email as spam if it contains the words online gambling. That would be a rule-based system and involves negligible intelligence and no learning. So how's this different from machine learning? Well, if a lot of people receive emails that contain the words online gambling and actually mark them as spam, then a machine learning algorithm will learn that the words online gambling are associated with spam. So in a rule-based system, you need to tell the software what to do, but a machine learning system can figure out what to do on its own. Another example is credit card fraud detection. Banks use machine learning algorithms to identify unusual patterns in transactions that may indicate fraudulent activity. Okay, what is transfer learning? You've probably heard about the different AI models being good at performing different tasks. Transfer learning is a method in machine learning where a pre-trained model is used as the starting point for a different but related problem. For example, if you trained a model to recognize a dog, you could use some of the lower layers in that model to start building a new model that can recognize horses. This saves a lot of time and computational resources because you're not building and training a new model from scratch. Now, this is a big deal in the world of AI because up until transfer learning was invented, you had different groups of people around the world building their own new AI models from scratch to solve a specific problem, and they generally worked in a silo. There was no way for one group of researchers to benefit from the work that was already done by another group of researchers. Transfer learning makes that possible, and it has triggered a massive acceleration in the progress of thousands of AI projects around the world. Okay, what is generative AI? Generative AI is a type of AI that creates new content. It's a way of training a machine learning model to generate novel outputs that mirror the statistical properties of the training data. So if we use text as an example, it generates text by figuring out the statistical probability of the next character as it writes the sentence. But this doesn't just apply to text. It can also be used to generate images, music, and synthesizing speech. So it is important to understand that this is the same fundamental technology that's used to generate the text, images, and music in most of the AI tools that you're hearing about, including IIMAGINE. For example, art creation. Generative AI like Midjourney, DALL-E, and Leonardo create new original pieces of visual art that have never been seen before. Now, this has created multiple copyright issues and changed the entire landscape for creative workers. I'll get into that in another episode about the impact of AI on creative fields. Another example is text generation. AI models like GPT-4 and Bard, that's B-A-R-D, from Google, and other open source models can write original poems, stories, and even technical articles, and do it with a very high level of quality, and do it in a few seconds. These models can create novel and realistic outputs, but they can struggle with coherence over long outputs, and they might also generate inappropriate or nonsensical results, because they don't truly understand the data in the same way that a human does. Okay, what's a vector database? Well, what is a vector? Everybody remembers from high school that a vector is basically a line in three-dimensional space. In this case, the length of the line and the position of the line represent different chunks of text. You can think of the position of the line as coordinates. So chunks of text are transformed into numbers and coordinates that represent the semantic similarity of the text. And vector databases provide the functionality for storing, indexing, and querying these high-dimensional vectors. So how is this different from a regular database? Well, instead of storing data in a cell in a regular database where the location of the data is determined by the developer, data is sorted and stored by semantic meaning without direction from the developer. Applications of vector databases include recommendation systems, image and voice recognition systems, natural language processing, and any other AI application where efficient similarity search in high-dimensional spaces is required. Okay, what is natural language processing, or NLP? It's a field of artificial intelligence that focuses on the interaction between computers and humans through natural language. The goal of NLP is to enable computers to understand, interpret, and generate human language. So in the simplest of terms, NLP is a field of AI where the objective is to create a way for humans to be able to interact with computers by talking to them. Now, NLP does involve several complex challenges, including understanding syntax. This involves analyzing the grammatical structure of a sentence. Semantic analysis. This involves understanding the meaning of a sentence. It understands that hi and hello have the same semantic meaning. Dog and puppy are closely semantically related, and dog and Mars are semantically distant. Then there's the pragmatic understanding. This goes beyond the literal meaning of words and sentences in isolation and tries to understand what is meant in context. So this can involve things like detecting sarcasm or irony, or identifying the purpose of a sentence. For example, is it a question, a statement, or a command? And then there's discourse analysis. This involves understanding how sentences in a conversation or a document relate to each other and to the overall context. And of course there is speech processing. So this includes tasks like speech recognition, which involves transcribing spoken language into written form, and speech synthesis, which involves converting written text into spoken language. Okay, what is a neural network in the context of AI? A neural network is a model inspired by the way the human brain works. The objective of neural networks is to solve complex tasks by learning from data. A neural network, like a human brain, is made up of layers of interconnected nodes, or neurons. Each node takes its input, performs a computation, and then passes its output to nodes in the next layer. The process is repeated, layer by layer, until a final output is produced. One way to think about neural is that it's the opposite of linear. Instead of trying to solve a problem by reviewing literally every possible solution, it identifies key data points and patterns and uses them to narrow down the number of possible solutions. Then it repeats the process until it eventually decides on a solution that it believes is statistically most likely to be correct. Check out the links in the description. I'll see you in the next video.